Hello, everyone. Welcome to our new episode of Digitalization of Utilities. Data and digitalization plays a central role in delivering net zero future. The topic for today is an innovative net zero planning tool for local authorities, energy network operators, and consultants called Local Area Energy Planner Plus or LAEP Plus from Advanced Infrastructure. And I'm excited to introduce our guest today, Lily Cairns Haylor from Advanced Infrastructure. Lily is a co-founder and head of product at Advanced Infrastructure. Lily, welcome to my show.
Great to be here, Nina. Thank you for having me.
I was very eager to record this episode, and finally we are here. The LAEP Plus tool showcases how harnessing the power of data can help solve complex problems and reduce frustration during the capital project readiness. I think this is one of the kind solution for local authorities, energy network operators, and consultants. So this is how we are going to structure our discussion. We'll start with an introduction of company, the challenges that you address, and services that you offer. We'll talk about the two case studies that you have and talk briefly about the competition and then the market you operate. And then finally, we will close with a golden question that I ask to all my guests. What does digitalization of utility means to you? So without further ado, let's start with the introduction of your company, Advanced Infrastructure. What does company do?
Yeah, sure. Thank you for the intro, Ninad. So at Advanced Infrastructure, we're a Cambridge-based company. We've been around for about 4 years, and we're operating in the space of energy transition planning. So broadly, that means working across private sector, public sector, and utilities to try and bring together the data and the models and the information needed to look at both near term, how do we decide where we're going to put what technologies, but also over the next 30 years, how do we look at building out realistic and feasible decarbonization pathways that get us to net zero?
Mm-hmm. And on your website, you mentioned the shared frustration among the founders that led to formation of Advanced Infrastructure. I think there must be some really interesting story behind it. Would you like to elaborate a bit more on it?
Yeah, sure. So when we first started the company, one of the early projects we did was through the Modernizing Energy Data Task Force. And we were funded to run a large-scale research project looking at energy planning. So near-term projects and long-term, full-scale local area energy plans, and try and identify where there were common challenges and common blockers. And I think I personally interviewed about 150 people. And the thing that got to me, and it definitely was a frustration, was that the same blockers come up repeatedly again and again and again. And you saw local authority, private companies, utilities all trying to get to the right outcome, but they were getting blocked repeatedly at the same processes. And this was impacting net zero, essentially. It was delaying getting charge points in the ground, getting heat pump projects going, getting smart local energy systems running. The enthusiasm was there, and often even the funding was there. But the information to understand where to put projects, the ability to collaborate across these different organizations was really difficult without common tools and common data formats. And the ability to just model and plan what was quite a nascent industry, so looking at how do you model, for example, smart local energy grids, that information was often missing. So you had the enthusiasm, you even sometimes had the funding, but again and again and again, we saw that this was getting blocked. And what was commonly described as a solution, which was local area energy planning, was something that was helping local authorities get partway, but once they had a plan, they would really struggle to actually implement it. And that was where we saw these challenges that affected planning really come into play, because if you don't have the data you need, it's all very well having a plan that says we want to site X number of heat pumps or X number of EV charge points. But if you can't actually find the addresses and the street corners where you're going to do that, you can't get assets in the ground. And it was those problems that we sort of identified quite early on and recognized that we might have the skill sets to try and help solve.
Yeah, and I think it's a very common problem all over the world that capital projects, especially in the utilities, require a lot of approvals and a lot of capacity planning and everything. And that just delays the project for endless time and the opportunities are quite lost. And I think that's what your LEAP Plus tool is about, right? So what exactly is this LEAP Plus tool and what challenges does it address?
Yeah, LEAP Plus is sort of kind of jokingly called that because local area energy planning as a process was already in existence. And we saw that there were some problems when you come to implementing it. So we developed LEAP Plus as the next step that a local authority or a utility or a consultant can go to actually start getting into the granular detail of, we've got an idea, we've got a target, but how are we going to get there? So broadly speaking, what the solution is it's a geospatial platform, a map, integrated data sets, and BI tooling and analysis. So you can use it to visualize data sets and triage sites for siting technologies, either in really small local areas, so one building, for example, or one street corner, one LV cable, or you can use it to try and create large-scale regional plans, so heat decarbonization strategies for a whole area. And really the reason why we found this is a solution that works is because of all the challenges we were talking about earlier. Because as you point out, Ninad, there's an enormous amount of sign-off and an enormous amount of information that's needed by organizations involved in energy planning. And the problem is it's not one organization, it's many. And they all have their own sign-off procedures. They all have their own data gaps and knowledge gaps. So by having a common place to work and a common workspace, because it's an entirely cloud-based platform, you can share data, you can visualize data, you can visualize plans, you can edit them, you can model energy systems, and you can do that on one platform. So everyone's on the same page. You can move a lot quicker. You can access the data you need instantaneously, as opposed to perhaps going out and asking a consultant to model this data for you, which would then rapidly become out of date anyway. So that's where LEAP Plus sort of really came into its own in trying to make energy planning not a one-off activity, but an ongoing process with a live SaaS tool that can support that.
So how does this tool work? What is the interface and how does a local authority planner would use the tool versus the same energy network operator might use the tool? How would that differ between multiple parties?
So we have persona-based functionality, which for those who know will know what that means, and for those who don't, it might sound quite boring. But it essentially means that depending on who you are and which organization you come from, the journey that you go through in a software tool is different depending on your needs. So because we spent a long time working with these different clients, we have an understanding of the types of data they need or the types of modeling activity they need and the licensing permissions that they have for data access. So as a local authority, when you log in, the data that you see might be different to other local authority users or DNO users or other utility users because you don't have data access permissions or because you're not focused on doing the same sorts of tasks. So for a DNO user, you might want to know, for example, what the impact on reinforcement is going to be of all of these projects and plans that local authorities are creating. And you want to know that across very large areas. Whereas for a local authority, you might be more specific and more focused. And if you're an EV team within a local authority, you're even more focused. So as far as possible, we've designed the tool to meet the specific needs of the different teams that are working in the energy transition.
Yeah, and you talked about the data because everything is going to be driven by data. Data forms a very crucial element in any analysis that you bring out. How difficult was it for you to get the required data to provide such insights? And what frustration while you were collecting or even cleaning that data set might be?
Data in the energy space is a challenge, and that's an understatement, I think. So we work across, I suppose you could say, three broad groups of data sets. One is looking at utilities. So, for example, electricity networks and electricity network capacity, which has its own cluster of problems. The next biggest category is building stock. So, for example, looking at EPC rating or building fabric, heat demand, energy demand, gas demand, information that you need essentially to model. And then the third group is looking at low carbon technology potential. So that's assessing, say, a building or a street or a region and looking at the suitability of that area for a particular technology. So rating buildings by suitability, for example, heat pumps, air source or ground source heat pumps, or rooftop PV, or district heating, or EV charge points. And it's really those three areas that we've worked across. And the challenges with data tend to be either that the data isn't available, or that the format is inconsistent, or the data quality is poor. So what we do and what our data science team does is wherever possible, we take data and we collect it. So say from network data portals. And then where that data is missing, we model to try and infill the gaps. So for example, if loading information on the electricity network is unknown, we apply rules-based algorithms to ascertain what we think the likely demand is for buildings within that network area. And we apply rules to associate network cables and the connectivity with the buildings in that area so that we can start to estimate things like load and start to use things like building fabric to ascertain what types of assets residents and local authorities might start placing on those properties. So that's a benefit for network operators because you know where you might start seeing things like PV or EV charge points getting connected to your network and where you probably won't. But it's also a benefit to local authorities and consultant planners or even private developers who are trying to find opportunities to get these low carbon technologies out there.
Yeah, because you have multiple stakeholders or multiple parties in it. First thing is getting the data. Is there any challenge in getting that data in first place or finding that data source in first place? And the parallel question is this new recommendation that has come out from Energy Data Task Force and Energy Digitalisation Task Force of Presume Open. That's still in progress. I don't think we are there yet because we are still working on getting that thing implemented. But getting that particular data set must be a bigger challenge for you to identify which data sets you want, where to find it, and how do you get those data sets in first place to power all your algorithms.
Presumed open is definitely the right approach, but you're right, we're nowhere near there yet. So if you take the example of electricity network data, every single DNO makes different data fields available. So one DNO might give you line impedance and 5 other DNOs won't. Some DNOs will give you 11 kV data and some DNOs won't. And there's a lack of consistency, and there's also a lack of consistency in the formats that gets published in. And what we always try and say to our DNO clients is, it's not a problem, just make it available. Make everything that you can available within restrictions and within certain regulations to make sure you meet national security, but don't worry about data quality. Don't worry so much about formats, just make it available. Because you have some DNOs who make certain things available and others that don't. So there's a lack of kind of consistency across the industry in what's around. And we are moving towards, more consistency and DNOs are increasingly publishing network data in common information model formats. But it remains a real challenge for organizations like ours because we're trying to support organizations at the forefront of the energy transition to get assets connected to the network. But they can't do that if they've no idea what the cables in the ground actually look like, where they are, or what the capacity is, what the voltage levels are. So it really helps when you can make your data open, and we will handle the challenges of when it is. And that's very much why companies like ours and many others exist, because we can process data, we can infill gaps. And even if there's errors in there, it's better to have something to start from than nothing.
And you mentioned one very specific point about the last mile data, the low voltage data. Usually what I have noticed, I have been working with UK utilities for quite some time now. It's very difficult to get that last mile data. And I don't think, at least in my experience, I have never seen any data set with last mile. How did you, and especially when your tool is focusing on local area planning, it might be very important for you to source that last mile data. How difficult is it to even find those data sources?
Yeah, the problem that you have with last mile information is that often, to be fair to them, distribution network operators won't know the data themselves. maps were not always retained, or sometimes it wasn't even logged where a cable was put in. So wherever the data is available, when we work with the DNO client, we take it in whatever format we can. And we also sometimes work with third parties who clean and process that data, like a company called Dairyherk that we're working with alongside Scottish and Southern electricity networks. Or where it's just ourselves doing it, what you can do is you can apply a number of rules to try and infill that information. So certain rules around how far a cable can run away from a substation before you'd get a critical voltage drop. So you can limit where a cable can run to. And you can follow assumptions such as rules that cables run parallel to roads, because typically they do. And that falls apart in rural areas, but for urban areas, it helps you quite rapidly fill in gaps to the network. And there's a lot of approaches you can use to try and infill that information. But you're right, usually there's a lot of difficulty accessing it. One of the projects that we've been involved in and we've been providing a mapping tool for has been Project Leo. And that's one of a test bed that there's been for Scottish and Southern electricity networks to try and map out LV network data. And that's literally involved sending engineers down to map out areas of only a kilometre squared and spending days literally knocking on people's doors, going down the street and trying to identify where cables are. Obviously, that's not scalable and you need a more digital approach, but it gives you an idea of the difficulties that there are in trying to establish for certain where these are, let alone what the loading or the rating of these cables are. Just where they are is a challenge.
Yeah, certainly. I can imagine that. Can we dig a bit deeper in another case study, which is a spatial analysis of the charging point? What exactly that case study is, what sort of challenges it's solving, and how LAEP Plus is helping solve those problems?
Absolutely. I mean, to put the EV charging challenge in perspective, as of I think last week, because I was on their website recently, ZapMap reported we had about 37,000 EV charging devices in the UK, which sounds good. But when you look at the targets that we're heading for, the estimate is that we're going to need around 300,000 EV charge points by 2030. That's from the Committee on Climate Change. There are other different estimates, but around 300,000 seems to be the number. And if we're going to hit that, that means we need to site, on average, 40,000 EV charge points per year between now and 2030, which is more than the number of EV charge points that are actually in the ground at the moment. So there's a huge blocker, and it's a really good case study of the challenges that we are kind of trying to address. Why is it that we can't get cables in the ground? Well, some of it's funding, but largely it's not. There's quite a lot of funding available through on-street residential charge point scheme and the new Levi fund for local authorities. And there's a lot of drive from private organisations too to site charge points. But where you have challenges is usually in trying to either get a connection to the network, which is commonly very constrained, and you'll often have electricity network operators simply saying, we can't because there's not space in this place you're trying to connect, or we can't right now. The second problem is if you can't find out where you should put them, and you have to send out, say, hundreds of site engineers to go and have a look and survey and find places. That's not scalable. So if you can bring in digital tools, either ours or other people's, you can start to quite rapidly triage these sites and understand where's suitable. So to walk through what we typically do in this process is, say we're working with a local authority, we bring in a number of different data sets that they can use to do those desktop surveys themselves and avoid as many site visits. So we bring in our own data sets looking at, say, pavement suitability for EV charge points. And that's an assessment of where there's street furniture that might get in the way, where pavement widths are too narrow for an on-street charger, or where there might be underground assets in the way that would prevent you digging down. And we also do combine with that network capacity. So if you take a data set like that and you combine it with other information around, say, charging demand from residents, how many EVs are there at the moment, how many residents are there, what would we expect utilization to be in the coming years, and you combine that with information about whether or not these residents can charge at home. So another data set that we produce or work with third parties to make theirs available is looking at whether residents can park off street. It's a really simple question, but when you look into the data, it's hard to answer. Because if a resident can park off street, then they're probably going to charge at home because the rates are much better. If they can't, then they need public charging infrastructure. And it's that sort of typical flow that we go through with local authorities to help them identify where there's a charging need and then where there are actually pavements or car parks that are suitable for those charge points.
Okay.
And the other thing I would probably highlight as well is commonly there's a bit of a blinkered view that you have to get charge points in and that's the only way. But the other thing that we also work with local authorities to do is highlight where you can have public transport black spots. Because it's not just about transitioning to EVs, it's also about getting cars off the road. So one of the data sets that we make available on our platform and which we build for that is called public transport accessibility levels. And it is essentially a scoring system that looks at how accessible the public transport network is from any given location. And the use of that is you can see where you have areas that are terribly served and you maybe need to improve, say, bus routes or trains. But you also know that that's most likely to be the areas where EV charge points are going to be needed because residents are going to be relying on their cars. So DNOs start to get an idea of, okay, we're going to have charging demand here. And local authorities start to know where they need to focus their efforts.
Do you also consider what sort of embedded generation is and how do we source that electricity more from renewables rather than getting directly from grid? How does that get covered, or is that a consideration?
It is. So there's kind of three, I suppose, different buckets that we look at for that. As of last year, nearly 50% of UK generation was renewable, which is a really good figure. I think it was about 45%. But the challenge we have is as more and more industries electrify, that demand is only going to go up. And the need for renewable generation gets higher as well. And of course, as you get closer and closer to 100%, you have more and more of a challenge of intermittency because renewable generation isn't available all the time. So what we do is three things. We look at where you have information from, say, the embedded capacity registers about where generation assets are currently. And then we look at where you could put generation assets. So, for example, if a given building is suitable for PV, that's one of the data sets that we offer. We do desktop assessments of buildings in an area and we look at whether they're suitable or not, or whether the land parcels are suitable or not, and what their generation capacity might be. And then the third element is in looking to help our clients understand what impact that would have on the electricity network, so that they can have a two-way dialogue with the network operators to plan the best places to put these generation technologies.
And how does then this case study is helping in savings or benefits for a capital project or even for local authority? How much time has been saved or how much cost gets saved? Is there anything that you can share on that?
Yeah, of course. So to take the example of an EV charge point siting project where, say, over a city, you're trying to site 100 EV charge points. If you do that in a traditional way with site visits and conversations with, local authority employees and trying to understand where the best places are, you have two problems. It takes a long time to go and do all these site visits. And your second problem is, because that's time consuming, you don't look at as many sites as you should. You just look at the ones you know of. So you're probably not picking the best. So the savings come from three places in this example. One is you spend less time doing site visits. So your employees, you're not paying them to do that. You're not paying them to go and visit. You can do it on a desktop and from your office a lot quicker. The second area is in picking better sites, because if you pick the best sites, your residents are happier, which is a co-benefit, but you also get higher utilization rates. So as either a private charge point developer or a local authority, you stand to make more profit from your charge point because people need it more and they use it more if it's in a better place. And then the third element is looking at the utilities. It costs network operators a fortune to reinforce the grid, whereas if you can try and nudge local authorities to connect in perhaps areas where there are fewer constraints, then you can try and flatten out the curve that's required for network investment and reduce the expenses that have to go into that now. And in future, you can also give them an indication of where they're going to have to invest ahead of need. Because when you have hundreds and hundreds of local authority planners building out projects on a WebGIS platform, you can obviously take that data and give DNOs insight and information on where you have clusters and hotspots of demand or generation coming into your network now, but also in future, because you know what they're planning to do. And that can save a lot of money for DNOs when trying to plan out where they're going to put that reinforcement.
Okay. So what other use cases are possible for this LAEP Plus, and what would be other partners that you would be working with in energy market?
The two main types of use cases that we support is either technology specific projects. So where can I put in district heating, or where should I put in district heating is maybe a better way of putting that. Or air source heat pumps, where should I electrify? Where should I put EV charge points? Where should I put renewable generation now? And that's one type of use case that we work on. And we do that with local authorities, but we also do that with private developers. So that's quite a booming market, particularly with regard to generation and EV charge points. Maybe less so in heat at the moment, but that will come. And then the second type of use case is in that long-term planning. So not that many local authorities yet have detailed decarbonisation pathways. Essentially, either a local area energy plan or a local heat and energy strategy, something that looks holistically across the area over decades and looks at how are we going to get from where we are now to net zero. So those are the two main use cases that we support. It's that near-term, very often technology-specific plan, and a longer-term whole systems view of how are we going to get from where we are now to something that's net zero.
Certainly. So what markets are you currently operating? Is there anything that can spawn out of UK, within UK?
So at the moment we operate primarily within GB, but we do have a number of EU-based clients. We're a software and a data company. So we build LAEP Plus, which is the tool we've mostly been talking about today, but we also build a number of different data products, looking at low carbon technology potential, carbon intensity, and electricity carbon intensity specifically. And we operate in our data side of the company, we operate in the EU as well as in the UK. And there's a real growing interest in Europe and in America, and increasingly beyond that as well, in how data can be used to inform decarbonisation strategies. And that's the case in local authorities and public bodies and municipalities, but it's also increasingly being driven by the private sector and by private corporations who want to prove to their own clients, their own buyers, that they're sustainable, or to their own investors that they're sustainable. And that's something that we work with quite closely in the EU as well as in the UK. In energy planning specifically, at the moment, we're predominantly UK focused, but there's a lot of common challenges that the UK grids are facing that we've seen repeatedly in other countries in the EU and in the US.
Yeah, and because you are sort of bridge between the private companies and government-owned entities like councils and municipalities, usually when you talk about public-private conversation, do you think there are any difficulties in the areas that you're working to bridge that particular gap of compliance, and specifically in getting those approvals? And it's very difficult when it comes to dealing with government agencies, isn't it? How are you trying to solve that, or how are you overcoming those challenges at this point? And whether that challenges will grow when you start going outside of the UK boundaries might be?
I think two of the biggest challenges that we find in the public and private spheres when we try and bring them together is one in data sharing, which we've talked about a fair bit already. So just the fact that data formats are different in different sectors and the language used can be completely different. I mean, it's all Greek to me is what several local authorities tell me when they have to deal with utility networks. They don't understand any of it. And why should they? It's not their day to day. So that's one of the big problems we have. And trying to bridge that understanding gap is something that we work very hard on. But the other side, the other challenge that I think is also really worth highlighting is bridging the private sector in terms of funding and investment with energy planning. It's really, really hard at the moment to get something like a local energy plan, a whole systems energy plan funded privately. And it's traditionally, so far, it's mostly been done through grant initiatives or government funding. But if we're going to try and transition, in the UK, over 300 local authorities to net zero, there needs to be private investment. That the energy transition needs to pay for itself, and it should do. And the business case is definitely there. But trying to bring public sector bodies and private investors together, it's not something that's done as often as it should be. And that's one of the challenges that we're actively working on, to try and make it easier for investors to spot opportunities and easier for public bodies to try and access private funding to progress their plans.
Yeah, because that's a very, very niche and very important gap that needs to be addressed everywhere, I believe. And it's very difficult to bridge that particular gap between those two parties. So who are your key competitors, would you say?
Well, I mean, this answer you maybe will find a little bit trite, but inertia, frankly, is one of the biggest competitors that we have. There is sometimes a willingness or a comfort in keeping to doing things as they've always been done. So, for example, bringing in consultants to try and solve every problem. You need consultants, you very much do, but you maybe don't need them for every single step of the way. And, consultants can't service every local authority every step of the way, and they should be doing the really hard work. So that kind of inertia, we often have to be competing against that as much as against other organizations, because you need to, one, show a business why they should be trying to decarbonize, because not everyone thinks they should yet. And you've also got to convince them that doing it in a digital way is more impactful and saves them more money and more time than doing it in a manual way, in more sort of traditional methods. So that's probably actually one of our biggest competitors. But otherwise, I think we often wind up competing with, say, organizations that are focused on more traditional methods of doing energy planning. Wherever possible, we try to work with them. And I think there's a lot of value to doing that, because consultants who do traditional local energy plans have a wealth of experience to bring in. At the end of the day, your local authority or your private organization, they want a digital solution and they want data that remains live rather than, say, a PDF report at the end of a project. So commonly, we end up competing with consultants, but wherever possible, we try to work with them.
Yeah, that's the key challenge. Okay, so we are nearing the end of our session. So our last question to my every guest is, what does digitalization of utility means to you?
It's the only way you're going to get to net zero. There is no feasible way to plan distribution connected assets at scale without it. If you're only connecting a handful of generation assets and they're all going through transmission, then maybe you can get away with the old methods. But at the moment, we're seeing millions and millions of assets, hundreds of thousands that need to go in the next few years, and eventually millions connected at the distribution network. And that can only be done if you digitalize. Otherwise, your connections team are going to be completely overwhelmed. Your local authorities are going to be furious because they can't get anything connected to the network. And you're not going to be able to plan as well as you want. So lots and lots of DNOs are moving towards this at a pace and very rapidly. And yet, to me, that's the only way that we're ever going to get anywhere near net zero. And only if we do so within the next couple of years, because otherwise time runs out.
Yeah, certainly. Okay, Lily, thank you for taking out time. It was wonderful discussing this amazing technology and tool that you have developed to help solve net zero problem. I'm very thankful for you to take out this time and coming on my show.
Thank you very much, Ninad. It's really good to be here, and I really like the topics you discussed, so thank you very much.
Thank you.